Our next session chair is Dr. Dheeraj Rane. Dr. Dheeraj Rane is currently working as Associate Professor in Department of Computer Science and Engineering at Medicap University, Indore. He has done PhD in Computer Science and Engineering from Indian Institute of Technology, Indore. His current research interests include cloud computing, economics, and machine learning. He has published papers in various journals, including Essay Index journals and IEEE Society International Conferences. Thank you, sir, for joining the session. Our next session chair is Dr. Hazrat Ali. Dr. Hazrat Ali is currently a researcher in artificial intelligence and healthcare at Ahmed bin Khalifa University, Qatar. Previously, he was senior researcher at Biomedical Engineering R&D Center of Human University Hospital, Sudan. His research interests lie in unsupervised learning, deep generative and discriminative approaches, medical imaging, and speech and image processing. He has co-authored more than 50 publications in various international journals and conferences. Thank you, sir, for joining the session. Now let's begin the paper presentation. Before we start the presentation, there are a few instructions for the participants. Each participant will get 12 minutes for the presentation, out of which last 2 minutes is for question answer session. So I request all the participants to follow the timeline. And also I request all the session chairs and participants on their videos.
Hello. Hello. Hello.
Yes, sir.
Please, can you read the paper for this section so that I'll be sure that we are in the right place?
Pardon, sir. Your voice is not clear. Yes, sir.
Okay, I can see it now. I said you should let us know the paper to be presented here. So so that we know maybe we are in the right place.
Yes, sir.
So these are the paper that are to be presented here, ma.
Yes, sir.
Then we are not supposed to be here. What is this, for God's sake?
Okay. Here in this session, we have, yes, sir.
I've seen it. We are to present the last one, 455.
Okay, here in this session, we have 5 papers to be presented. A request to the session chair to start the session. Over to session chairs.
Okay, paper 45. That is brain tumor segmentation using deep neural networks, a comparative study. You can start sharing your screen and start the presentation. Yes, anybody from paper ID 45, just at least acknowledge that you are here so that we can continue with your presentation. Pankaj Gautam, Rishabh Goyal, Udit Upadhyay, Dinesh Naik.
Paper ID 455 is ready for presentation, sir.
Hello, sir.
Yes.
Yeah,
sir,
Mr. Pankaj, please
Yes, sir.
start the presentation. I think everybody is
Sir.
waiting for you.
Okay,
I invite
Sir, I'm
our first
audible?
presenter, that is paper ID 45, presenter Mr. Pankaj Kumar Gautam. Mr. Pankaj Kumar Gautam,
Miss-
kindly share your screen and start the presentation.
It's Mr. Sunday Agbaje that will present on his behalf. He's not available. Paper 454.
55, sir. 455, sir.
Okay, your own is 455.
Yes, sir.
Okay. Sorry.
I am
Yeah, yeah.
audible. Okay, sir. Actually, sorry for the inconvenience. Screen. Can you please help me in sharing the screen?
Do you face any specific problem or
No, sir. Like there is no option.
no? If
for
you are on a computer, it is just in the lower part of the.
okay,
Just
sir.
move your mouse cursor to the lower part of the Zoom window, and you should be able to see a green. Says share the screen.
Start focus. Sorry, sir, but I'm not able to get the like the share screen option. There is no green color icon or menu in my.
So you can retry again. You leave
Already
the
it is
session
hidden, but
and
once
just
you move the mouse
rejoin.
cursor. Yeah.
Okay, sure.
Till then, we can call next presenter.
Yes. Paper ID 73, diagnosis of brain tumor using lightweight deep learning model with fine tuning approach. Tejas.
Yes, sir. Hello.
Tiladkar and Urvashi Bansal. You may please start the presentation.
Hello. Am I audible?
Yes.
Yeah.
So yeah, let me share. So hello.
Not yet.
Kindly share your screen.
Is it visible? Yes, sir. I have started yours. It is showing your screen sharing. So is it visible now? Hello.
We'll let you know once it is visible.
Okay.
You can just try it from your end.
Hello, sir. I am presenter for. I am ready for with my presentation. So can I start sharing the screen?
Just wait. I think we are done with 73.
So actually, it is in your. It is showing your screen sharing.
Okay, but at least for me, it's not visible.
Yeah, I also do not see the
Okay,
screen.
let me try it again by joining.
Unshare and then share it again. Maybe that would work.
Yeah. Now.
No, not visible yet.
Still, it is not.
So, Kavita, are you sure that the settings of the meeting allows participant to share the screen? Hello? try to share my screen just for a few
Yes, yes.
seconds to make sure
Yeah,
that,
sure, sure.
this sharing is working.
Yeah.
You cannot start participant is sharing. So someone is sharing, but we don't know who. Okay. So I can share. Can you see my screen?
No.
No,
With a
not
PDF.
visible.
Okay, your shared screen can be seen only by the host. So I think
We need to change the settings.
yeah, the host need to change the settings because it is basically shared screen can be seen only by the host because the meeting is in focus mode.
So configuration needs to be changed so that every participant can see.
Yeah.
Yeah.
So who is the host here, Kavita? We do not get.
Okay, I'll call Ms. Kavita so that.
Sir, we have fixed the problem. Now you can try sharing your slides.
Okay, so first I will try to show everybody sees that, and then the okay. It still says that.
Yeah.
Okay.
Yes, it is visible, sir.
Okay, so I'm going to stop screen.
Yeah.
Presenter share his screen.
Is the screen visible?
Yes.
Yes.
Okay. So I will start. So good afternoon to all the jury members. I am Pankaj Kumar Gautam from NITK Surathkal, and I will be presenting my topic on brain tumor segmentation using deep neural network. And these are the others co-author who helped me in publishing the research work. In a survey conducted in 2020 in USA, about 3,460 children were diagnosed with brain tumor, having a age under 15 years, and around there were 24,530 words adults. Using the MRI, magnetic resonance imaging system. So brain tumor segmentation from MRI can significantly improve diagnostics, growth rate prediction, like how fast the tumor is increasing in the brain, and the planning of for the treatment, the chemotherapy, and the other medical help. So like there are some categories of tumor like gliomas, glioblastomas, and meningiomas. So in this research work, we deal with the like a specific type of tumor, that is glioblastomas, and like it can be anywhere in the brain, having different contrast. So the the study will explore two different types of architecture designed for medical image. So this is the literature survey. So like in the two cascade CNN design has already been proven to assist reasonable accuracy and resilience. The research verified that their methodology on MRI scan dataset for the BRADS 2013. So basically, that's the dataset, the BRADS dataset from the SMIR repository, and like it the MRI scans on yearly basis. So like our research basically focus on the 2013 folder or the 2013 data. And also, like the previous investigation also used the encoder decoder based CNN design for segmentation. And then there is VGG and ResNet design.
21, and the data set they have used it LC 25000. They use the method they use a feature extraction method with .NET 19, and they use manta ray forging and equilibrium optimization for optimization of features, and SVM for classification. By this, they have achieved the accuracy of 99.69%. The another paper is multi-input dual stream capsule network for improved lung and colon cancer classification. The paper was published in 2021. The data set they used is LC. And the data set they have used is LC 25000, and the methods for this they use multi-input dual stream capsule network with and without pre-processing of images.
Mahua Pal. Hello.
And by this, they have achieved an accuracy of 99.3%. Another paper is prediction of lung and colon cancer through analysis of histopathological images by utilizing pre-trained CNN models with visualization of glass activation and saliency maps. The paper was published in 2020, and the data set they have used it LC 25000. And methods they use feature extraction with the convolution neural network and support vector machine for binary class classification. They have got the 100% accuracy, but they get accuracy for lung and colon images, lung and colon cancer images. They have done only binary class classification. Another paper is ensemble transfer learning for lung cancer detection, and the paper was published in 2021. And the data set they have used is LC 25000. And in methods they use ensemble transfer learning using 3 CNN architectures. These architectures was VGG16, ResNet 50v2, and ResNet 201. And then they achieved the accuracy of 91%. And another paper is PDBL, improving histopathological tissue classification with plug and play pyramidal deep board learning. The paper was published in 2021 on the LC 25000 dataset. And methods they use pyramidal deep board learning with ShuffleNet v2, EfficientNet v0, and ResNet 50 architectures. By this, they achieved the accuracy of 96.48%. And another paper is deep learning based collateral cancer tumor prediction. The paper was published in 2021. And data set they have used it LC 25000. For feature extraction, they use 2 methods, LBP and Hawk filters, and XGBoost for classification. By this, they achieved an accuracy of 99.99%. Another paper is a transfer learning architecture based on a support vector machine for histopathology image classification. The paper was published in 2021, and data set they have used it LC 25000. And for methods, they use the transfer learning model for image classification. For image classification, they use SVM and softmax classifier. And they achieved the accuracy of 99.44%. The last paper is DHS CapsNet, dual horizontal squashed capsule network for lung and colon cancer classification from whole site histopathological images. The paper was published in 2021, and the data set they have used is LC 25000. And in methods, they prepared their own dual horizontal squash capsule network. And by this, they achieved the accuracy of 99.23%.
Mr. Ankit, you can shift to your work because please respect time restrictions.
Yes, sir. Yes, sir. Yes, sir. This is the problem description. In this paper, I tried to improve the classification of accuracy of LC 25000 dataset and do the comparative analysis of pre-trained CNN architectures on LC 25000 datasets. And these are the pre-trained architectures that I have used. Now comes to the data set. The data set belongs to the Pathology and Laboratory Service, James A. Haley Veteran Hospitals, Tampa, Florida, USA. And it contains 25,000 images of 768 into 768 pixels. And data sets have 5 classes, as we can see in the table: colon adenocarcinomas, colon benign, lung adenocarcinomas, lung squamous cell carcinomas, and lung benign classes. And that data set is Health Insurance Portability and Accountability Act compliant and validated. These are the sample images of the data set. And in this paper, I have used LC 25,000 data set for classification. For training, I have used 70% data, and for testing, I have used 30% data. For pre-processing, in pre-processing, I have resized the image for the convolutional neural networks. And after that, I simply extracted the features using extracted the feature using feature extraction method, and done the classification using multi-class classification approach, in which multi-class classification approach I have used 1 versus 1 approach. And after that, I predicted the result. These are the results I have predicted on the different networks, as you can see. And as we can see that Inception ResNet v2 has achieved the highest accuracy of 99.79%. And we have done the 5-fold validation method. By that, we get the 99.724% accuracy using the Inception ResNet v2 convolutional neural network. This is the confusion matrix of Inception ResNet v2. From that, we have achieved the highest accuracy. This is the conclusion. As far from the study, we can say that Inception ResNet v2 has the highest accuracy achieved by the feature extraction method on the LC 25,000. And this study may be beneficial for the researchers when working on the LC 25,000 data set. In table 2, I have done the study comparison of this for this data set. These are the references. Thank you. Any questions?
So I have one question here. Do you compare the accuracy only, or do you also perform comparison for other metrics such as, let's say, F1 score or precision and many other metrics?
Sir, I have a compare only on accuracy. For Inception ResNet v2, I have shown in the paper all other matrices.
Okay, and second thing, can you move back to slide number 11? I have one very quick comment here.
Yes, sir.
So, I mean, and perhaps it's not the way you have actually done, but it seems like from this block diagram that you are combining the training data and the test data into the pre-processing block. Is it that way?
I want to show that I have done the pre-processing on both data sets differently. For
yeah, but the figure basically reflects that maybe you are combining the test data into the pre-processing block with the training data, and then in the feature extraction block, we know that it's not that way we usually do it, but yeah, maybe you can consider to revise the figure. But anyhow, it's okay.
Okay. I will.
Okay, I don't have any more questions. Thanks.
I have one question.
Yes, sir.
You have shown many works in the literature review portion. How your work is different from those available works, because many of the works they are working on LC 25000 data. So is it only that you have used this cascade CNN model? Sorry, you have used this model CNN, and you
They
have used
have
multi-class classification.
they have done the feature extraction and classification from another method, but mostly in some papers they have done feature extraction using CNN, but they used another classification CNN networks or another classification approach. That's it.
Okay.
Okay. Can you explain the extraction process of pre-trained network feature?
For extraction, just we simply bypass the images from the network. Then after that, we get a matrix of features for which we can do the classification.
Okay, you have bypassed it.
I just passed it from the image. I just passed it from the network.
Okay, you have passed it. There is a huge difference. One
Sorry,
more thing, just a suggestion that presenting in a conference from mobile phone, that is really.
Sir, it is not mobile phone. It is a tablet. Sorry.
Whatever, but I'm looking at the screen itself. Means I'm using my laptop, but still I'm not able to get anything else. Whatever you have presented. So from next time, please try to follow the instructions.
Sure, sir. Sure, sir.
Yeah. Okay. Anyone from audience if having any questions? Okay. In that case, you can unshare your screen. We can continue with the paper ID 273. Supervision meets self-supervision. Mr. Saumitri Chattopadhyay.
Yes, sir. Good afternoon to the honorable members of the jury and the area chair. So I am Soumitra Chattopadhyay. I shall be presenting my screen. Is my screen visible to everyone?
Yes.
Okay. So well, this is a paper. We are from the Department of Information Technology, Jadavpur University, and our paper is Supervision meets Self-Supervision, a deep multitask network for colorectal. Setting up the premise for our work, our research work, basically is about analyzing histological slide images from colon and rectum images. And as we can see that in the background, this type of imaging based analysis, or rather medical imaging based histopathological analysis, has been approached in the past as well, but these approaches have been mostly limited to extracting the using very traditional techniques like image processing techniques and handcrafted feature extraction. These methods have been research community has shifted to deep learning methods, and especially with the advent of convolution neural networks, these methods have the capability of capturing very complex patterns and some features or representations, as we can call them. These features are translationally invariant. So what happens is that if we add the feature, find out that it's highly distribution, as we can see that from the statistics point of view, this colorectal cancer is one of the leading causes of cancer related deaths, and its early detection from any means its early detection can actually increase the survival rate by huge margin, that is 90%. And so the need of the hour is to develop an efficient technique, and we can see that in the medical practitioners available at a place and any given time is highly limited, and so this large scale histopathological screening is quite actually limited and inconvenient, and so computer aided diagnosis comes to help. Now coming to our methodology gradually. Now if we can look at this problem from a very layman point of view, we have some tissue images and we need to analyze them, or rather we need to classify them. So basically this problem boils down to a multi-class classification of the medical images, which are histological images. So if we come to deep learning methods for image analysis, the classical approach has been to use is to train a deep learning model and then use the standard cross entropy loss. The multi-class or the categorical cross entropy loss has been classically used for these kind of purposes. Now what we do is that we are interested in to find out a feature representation which can actually, it doesn't use the categorical cross entropy loss explicitly. What it does, it tries to find out a very efficient and a very optimized feature representation, which representation can be discriminatory by itself. So what our approach has done is that, if you can see this line, we have proposed a method that uses a concept called deep metric learning. Now metric learning, what is that? It essentially finds out the similarity and dissimilarity between samples, and then it tries to learn this similarity and dissimilarities. So essentially, if we talk about deep metric learning, which has been used in several domains like face recognition, and it has been used very much in signature verification, where we have a forged signature and an original signature, and the method learns to differentiate between them. And so in deep metric learning, this is the main objective, is to have, we have something called a positive samples and we have something called negative samples. So given one sample, we can have positive samples which should be closer to that sample in the embedding space, and we have some negative samples which should be farther apart in the embedding space. So our method actually uses deep metric learning instead of the classically used cross entropy loss that directly uses the labels. And along with this deep metric learning, what we have used is that we have taken inspiration from the literature of self-supervised learning. Now self-supervised learning has gained tremendous popularity in the last 5-6 years, and this is because the labeling of data, I mean, this data is often is available nowadays. A lot of data is available, but it's very hard to get the labels for the data, the annotation for the data, if you see. So this annotation and this labels of data is pretty costly and pretty expensive to obtain. So what self-supervised learning has done is that it proposes some algorithms, or it proposes a mechanism that helps us to learn this kind of explicit label autoencoder, that we have an image and we try to recreate the image. So with that, the image level features can be learned. We also have some contrastive learning based self-supervised approaches, for example, like SimCLR or Moco V2 or Moco. So where we have, like this, the two different augmentations of the same image are positive samples and all. So, and also we have that we take inspiration from these two fields, deep metric learning and self-supervised learning, in order to propose our method. Now coming to our method, we can see that our method, our architecture is actually quite simple. Our architecture has one encoder and our architecture has a decoder. And what happens is that for the encoder is basically taking the image and it's trying to generate a representation of this image. And then we have a decoder. Now for the decoder, what happens is it starts from the image
the mean field cascade architecture, where okay, so where the first the output of the first CNN block is directly concatenated the output of the with the output of the full this full two-path CNN block. And then we have the architecture block diagram. This is from the past research. And so like results and discussion, the model were trained on the cross entropy loss and like the Adam optimizer, and the testing was done on the rest 30% of the data, and the dice loss was computed for them as shown in this table 1. Is the result for the cascade architecture, like where we have 3 tweaks: input, local, and mean field cascade, respective scores for F1 and dice loss. And then unit benchmark model and their respective F1 score and dice loss. So like from here we can get that the local cascade, the tweak we have applied in the cascade architecture. The local cascade was the most efficient one and is very much comparable with the benchmark unit model, which like producing a score of in terms of F1 score, it is producing like 0.772, and the dice loss was also comparable, having 0.6679. So basically 6679 is very closer to 1. So from that from this score or from this number we can conclude that our is able to get most of the segmented tumor part from the and this is just a snapshot of the 30% of the testing MRI scan that we have done. So like here we this is the MRI scan, and this is the ground truth and then we have the prediction for the cascade CNN marked unit model, and this is the respective dice loss for. Here we can see that there are some values which are going to like very high. Like there are values which are like closer to 0.45. So like this is just a snapshot of the 30% of the data. Mean of like the average of the 30% of the data that in the table. So like what we have concluded is we have concluded that the local cascade CNN performs better than the input and the mean field cascade F1 score of the cascade architecture and the unit. And the unit obviously performed better, but like our tweaked word was almost very closer or comparable to the unit benchmark model. Okay, so like these are the references, the like the literature survey and the references and the data set we have explored methodology and research work. And like so a very well thank you to all the jury members, and like I'm now
Any question from the session chairs?
Yeah, okay, Pankaj, very nice talks. I have just one question here. Did you also compare the computational requirements for your cascade versus unit?
okay, so computational requirement in terms of like the amount of CPU power or the like in terms of this.
Yeah, exactly. In terms of the time required for the
sorry,
training.
sir. So
and,
like
yeah.
no, sir. So basically,
Okay.
this study aimed in terms of efficiency and not in terms like the computational efficiency and the
Okay,
power
okay, that's
consumption.
good. So yeah, it's just a suggestion. Like you can consider that in future because it makes your study very strong if you include those.
Sure. Thank you for the suggestion.
Mr. Pankaj, what was the data size on which you performed this experimentation?
Okay, sir. So like the 2013 data set we have used, and it was around 1.3 GB, and like the this was like the MRI scans, and you can call them the images. So like it was in 1.3 GB around, out of which 70% was used as training, and the rest was for the testing.
Okay.
Okay, how can you say that the system is more prominent than existing systems?
Okay, so like in the table itself, we can like we are conclude that it's comparable like the this tweak, the local cascade tweak that we have applied in the two-path CNN is very much comparable and closer to the unit benchmark. So obviously, like this gives a that the methodology that we have employed is good in terms of generating a good efficiency and a good system.
Okay, if nobody else is having questions, then you can unshare your screen. We will continue with the next paper, paper ID 73.
Yeah.
Hello, can you see my screen?
Yeah.
So hello. Yes, Shiritkar, I'm from NIT Jalandhar, and I'm going to present my topic diagnosis of brain tumor using lightweight. So these are the contents that I'm basically brain tumor is basically a clump of irregular cell that form a mass, which if the clump of irregular cause a permanent damage to our brain, and it may also lead to death. In India, these types of tumor range from 5 to 10 per 1 lakh persons, which is increasing. And the brain and central nervous system are the second most cancer. It's common cancer in children, account for about 26% of childhood cancers. So in last decade, various advances has been made in the computer vision field with the help of convolution neural network for better analysis. So this my approach was to help the radiologists or to aid the radiologists who are not who can assist them to visually analyze a tumor in a greater details. So there are basically two types of data which we can do that, which is first one is the MRI scan and the CT scan, which are the two methods used by doctor for detecting the tumor. Brain diagnosis is the segmentation. Many deep learning techniques have been used for this. In medical learning, deep learning models has various advantages over all the traditional machine learning algorithm. Learning so that we could use the train network model so that we don't have to do more computation as compared to our traditional system. So I show since deep learning has been has very advantages, and going to explain some. So basically, deep learning is a smaller part of a machine learning algorithm, which machine learning which solves complex problems using artificial neural network, which are designed using the brain neurons. So it mostly consists of the input layer, the hidden layers, and the output layers. The neurons, which are as a function and which are connected to the weights, which can be modified so that we could get an output which resembles our help for more precise accuracy. So since in the last decade, convolution neural network has been very helpful to in our in our in our brain tumor analysis. So basically, convolution is a small kernel which has some weights which we multiplied with the original image. As you can see here, we take an input of 448 cross 448 image, in which we apply a 7 cross 7 kernel, which 7 cross 7 kernel, which gives our neural network a 192 layer that it will have like 7 cross 7 kernels of 192 of 192. And as you can see, we can see that we perform kernel analysis on the input image to this, and as we train our model according to our different tests, we'll get an output which is traditionally helps in analyzing our networks. So the algorithm which I'm going to use is you only look once. Since it's a single stage detector, it has this name like you only look once, and it is very fast as compared to a two-stage detector, which has been used for the brain tumor diagnosis. So currently there are like 5 versions of YOLO. So YOLO V1 was founded by the Day-1 scientists. So YOLO V2 was introduced with better accuracy, which included the inker boxes, then variable resolution and resolution. Next one was the YOLO V4. This was also done by Dr. Redmond. So after which in 2020 it was the introduced the technique YOLO V4, which included the bag of freebies and bag of special technique, which generally help to improve the accuracy. Were trained at the frame up of darknet, but after almost after V5 was introduced, which was basically done on Python dependency, and the training of our model is quite easier in this. So for better understanding, I had to explain the YOLO model. So in YOLO model, we give an input image to the basically is used to help extraction of the feature extraction, and the next layer is helps for the mapping of the features. The fourth part is the dense prediction, which helps us to detect the image which we are going which are given. So it uses a bounding box which has the detection heads in the as compared, and this is the literature survey. So used for the brain tumor analysis with performing almost giving us a pretty good accuracy in 80%, 80 to 80% accuracy. So some of the limitations which I saw with the high time complexity, these are the literature which I had done, but the problems which I expensive this model, the classification models requires less resources as compared to the segmentation model to detect, but it is not give the result as same as the segmentation model. And the existing models for better accuracy require a large data set, but which large data set which can be obtained by the smaller healthcare strategy. Like if we have a smaller healthcare strategy which has a limited data set, and human intervention is needed for future actions and pre-processing of data set. So basically my problem statement is we will design and implement a deep learning model which will be computationally efficient and can work on a generalized data set with fine-tuning using transfer learning. So these are the objectives which I will try to develop a lightweight model using the fine-tuning approach of pre-trained to incorporate a hybrid strategy to which can work on custom adaptation. So one of the main two trade-offs which I will be doing is like if I am able to build a model which gives us between like 70% and still be able to do it in some precise time, so that it would be so that the healthcare facility can afford to perform this type of analysis on their own. So this is the methodology which I use. So first I had to take the YOLO V5 model has a transfer learning trained, which is an object detection model dataset. So we are going to use the train weights of from the train weights which are found by performing this on the dataset of this. And for this study, I choose the dataset which is the Brad's 2018 dataset, which is almost almost 120 GB, and it has like all the layer like T1 layers, T1 layer, T2 layers, which from which we can able basically 3D data which we can use to analyze this. And so this for the pre-processing needed, I had to specifically go to for training and testing. I have study only this is not fully done. Like I took 400 images and I the tumor, like do the bounding box thing for using the make sense website, which was able doing this for the training and testing of the dataset. After weights, I was able to detect the dataset which gives almost a loss of 0.28. Conclusion I did in my study was basically has been developed that many various models and toolkits are developed for the brain tumor analysis in the past, but the viability of the models in terms of real-time application has not been considered, like the resources needed, like for the as we know the GPUs which are used for this type of analysis purpose are literally are very expensive in terms. So for this I had some limited locations like I used like 16 GB RAM and some 8 GB GPUs, which is quite affordable. So in this I tried to I was trying to use the model YOLO V5, since YOLO V5 is currently the state-of-the-art model, which is faster than the other deep learning models. So this model is crucial for development of lightweight brain tumor. So I'm comfortable to design a model with this relatively reduced storage, which will find a feasible solution to be considered for variation. These are the differences. And thank you for giving the offer. And any questions?
Any question from the session chairs?
Yeah, I have one question. So nice talk. I was wondering if you also considered grading the tumor, or is it just limited to detection of the tumor region?
So currently, no, I haven't considered grading of the tumor. Yes, to consider many features for it. So yes, I haven't considered. It's limited to the brain tumor.
Oh, okay, sure. So another question. because you mentioned in the title that this is a lightweight deep learning, so you choose this lightweight title because it is a YOLO method, or do you basically introduce some changes to the YOLO to make it further?
No, so the YOLO because I choose the lightweight because it is. So I was using the model, the YOLO nano version for it, which is basically almost lesser than 4 times the size of the bigger models. So that's
Okay,
why I
okay.
choose.
Yeah, thanks.
One suggestion from my end is you also refer to the past on a computer-aided diagnosis of brain tumor using YOLO. So there are few works which are available, which you can, I think,
use contrastive learning for embedding space. So this is our work. And any questions from the chair? Any questions from the chair,
Yes.
sir?
So how many images have you taken into consideration?
Okay, so the image dataset has been the one proposed by Cather et al. In 2016, and it was one of the first multi-class texture analysis.
No, my question is how many images have you considered?
Yes, our dataset has 5,000 images across 8 classes, and we have split the dataset into 75% for training and 25% for testing.
Okay, okay, thank you.
Any other questions, sir? So any other question from the respected chair?
No, not from my side. Thanks.
Thank you, sir.
Okay, now we can continue with the last paper. Paper ID 455, a rule-based deep learning method for predicting price of used cars for registration. Dr. Nishchal Mishra.
Greetings, sir. Good evening, sir.
Hello.
Yeah.
Yes, sir.
Yes.
Am I audible?
Yeah.
This paper is presented by Ajagbe Sunday, and he's actually wrongly it is mentioned that this paper will present Dr. Nishchal Mishra. The author of this paper is already joined.
Okay, okay.
Yeah.
Am I audible?
Yeah.
Can you see my screen?
Not yet.
Hello, sir. Can you see my screen? The session chair and the
No.
coordinator.
No, Mr. Sunday, it's like your network is slow.
Yeah. Can I share your hello? Can I share your presentation?
Hello, sir.
From my side?
Please,
Now we
Yeah,
can
yeah.
see. We can see now.
My navigation points are the background, the literature survey, problem description, methodology, results, and discussion, conclusion, and as well as the references. Nowadays, the price of the demand for the automobile has increased, while the demand for the new cars has drastically 2000. The estimated price of used car are difficult and almost impossible to determine. Sellers are interested in the fair estimated price of these cars. This necessitated the need for the development of an accurate price prediction mechanism for the used cars. The use of machine learning methods can be helpful in predicting the price of the used car according to Schindler et al. 2021. The deep learning is a tool in determining in machine learning that uses the highly connected processing unit to perform supervised and unsupervised learning according to Ayo et al. 2000. The generic search used in the simple generic algorithm to perform the search for the best solution. Correlations-based feature selected subset evaluator evaluates the weight of the subset of feature based on the fitness of individual feature to the classifier along with the degree of intercorrelations between them. And of course, a rule-based engine uses its inference rule, and we have fully 2014 that is work aimed at predicting the price of used car in the Naira stores, and the method employed was assemble machine learning techniques. The experiment achieved high prediction accuracy. Also, RFN 2021 developed a second-hand Tesla car prediction model, and he also employed assemble machine learning techniques. And of course, the experiment achieved a boosted decision tree regression was shown, which is a better result among the model experimented. Now, the description of the problem in this presentation. The recent years has witnessed a rapid development of online shopping for the used car without correct price evaluation. And of course, like I said earlier, the estimated price for the used car are difficult and almost impossible to determine. From the literature, most of the classifier used for car price prediction suffer low accuracy rate and high error rate, and this informed this study. On our methodology, the approach we employ, we have the phases of the system, which include the data sets collection, the data preprocessing, hybrid rule-based features extractor, as well as a predictor. This is the architecture of our work, where we have the data set that was acquired, and of course, the data preprocessing section follows. We have a region, a section that is meant for hybrid feature selection phase that comprises of feature classification and all other feature evaluation, selection setting, as well as the genetic search. We have the rule-based engine, phase alongside with the selected features, and we have the prediction that employ artificial neural network in our proposed architecture. Now, the data sets collection and preprocessing. The data set for this experiment was acquired online and downloaded from the link stated above on the screen, and it comprises of the three types of entity. Under entity one, this entity one also subdivided into three, which are the specification of a car in terms of different features, which we tag between feature 3 to 25. We have 2, it's assigned assurance risk score, which is tagged feature 1. Then the third one is the normalized losses used in comparing the other cars, which is tagged with feature 2. The second entity relates to the increase, to the degree to which the car is more risky than the indicated price. And the third entity is the relative average loss payment per insured vehicle year. And the data comprises of 205 instances and 26 attributes. So we have the description of the data sets for the prediction of the used car. We have on this column, we have attributes, which comprises of the symbol, normalization loss, makes, the car makes, and the fuel type, and so on and so forth. Also, on the next column, we have the data type, which are integer, continuous, normal, normal, and so on. We have the attribute of data as shown, attribute arrangement of the data set as shown. We have our hybrid rule-based feature extractor, which is a correlation-based subset evaluator. So, and we have the genetic search that was used in this experiment. The rule-based engine returned a feature subset with fewer selected feature if there is exit from the other features subset with similar fitness, and the value and the fitness value otherwise it returned the feature subset with the higher feature value to the classifier. So we proceeded into the predictor. This predictor, as proposed in our architecture, make use of the artificial neural network, and of course suggested the price of the car, or predicted the price of the car. Among the techniques that we use for this experiment, we have a correlation-based subset evaluator, and we have M5P, we have the KNN, as well as support vector machine classifiers. And all these things, all these techniques were evaluated in the experiment. The result of these different classifier for the prediction of the used car are shown on the screen, where we have all these parameters, the evaluation metrics include the correlation coefficient, mean absolute error, then the root mean square error. Those are the three metrics used for the evaluation of the performance of the techniques employed. So the result and discussion also continue by showing the algorithm of the experiment, the feature that was selected, the features, as well as the features selected, their accuracy, This is the comparison of the algorithm for the
कौन है?
for the feature selection.
ये इसी का प्रेजेंटेशन चल रहा है, इसका उसी का है, ये अभी चल रहा है उसका.
Hello? Hello?
Yeah, please continue.
Hello?
Yes, continue.
Can I still continue?
Yeah, please continue.
Okay, sir. So result and discussion continue. Among the four techniques employed for this experiment, this is the results, the other result outlook, though I've earlier presented similar thing in the graph earlier. So this shows the better comparison of the techniques where we have correlation-based subset evaluator having 0.9818 in the correlation coefficient, which is a bit better than M5P and that of KNN and support vector machine. Also, root absolute error, mean absolute error of 1.18009, which also better off than other techniques employed. So we have root mean square error of here under root absolute error, the support vector machine perform better than the correlation-based subset evaluator. And here we have root mean square error as well, where we have support vector machine that perform better than other techniques employed. So now this is the comparison of the classifier that's employed in this experiment. So we have the actual values of the results as well as the predicted value. This is the simple prediction result of the developed car price predictions. So on the conclusion, the hybrid feature selection based on the rule
I think we lost your audio. Hello.
and additional neural network model was used for used car price prediction. Use a robust architecture prediction through the feature model include correlation evaluator. So the rule-based engine check the similarity feature subset, and the feature subset with the fewer features is returned. The ANN return based on the final price prediction on the selected features.
Screen is not visible to me.
Your screen is unshared. Kindly share it.
Sharing the screen. Hello.
Your screen is not visible. Please reshare your screen.
Hello. Hello.
Yes, you are audible. There is a network issue.
Hello. Hello.
Hello, you are audible, but your screen is not shared. You can share. Can you share once again your screen?
I'm trying to do that, but I don't. The menu is not enabled. Menu is not enabled there. Hello.
Yes.
Yeah.
Having issue sharing. Okay. Trying to rejoin the meeting. Can you see my screen now?
Yeah,
Yes.
we can see. Yeah.
So on the conclusion, correlation-based subset evaluator was the best with the research evaluation used in the correlation coefficient mean as absolute error and root mean square error with the following result of 0.9818, then 1.1809, as well as 1.505 respectively. The result of the evaluation conducted shows that developed model outperform other related and existing model. The contribution to knowledge of this paper was the design of an hybrid feature selection technique based on the rule for the car price attribute selection. Then the use of deep learning method for predicting car price of used car. Sorry, the use of the deep learning method for predicting price of the used car. These are part of my references. Thank you for your rapt attention, sir.
Okay, thanks. So I have one question here for the presenter. I think you used the dataset from UCI repository. So I was wondering what motivates the choice of your data, and because I guess it is a data from 1980s or 90s. So how would it fit to a problem today? Yeah.
Actually, the data, I cannot remember the data or the date of the data acquisition, the date when the data was actually published, but the data is not up to 80, sir. Can be up to 80, and it's very suitable for the proposed architecture.
Okay. Yeah.
One question
Maybe.
for presenter. After feature selection, how many features got selected? I mean, there are 26 attributes initially. After you applied this feature selection technique, how many features got selected?
5 features were selected, and they were selected based on the parameter set for the experiment. So whereby when the fewer sorry, where the related features were selected for the next stage, while the one that are with lesser parameter will be returned back to the initial stage.
And what was there in this rule-based engine phase? What rules?
Sir?
What kind of rules you formed in this rule-based engine?
The rule that was found in the rule-based engine was supported based by the generic search.
Okay.
Any question from the session chair, or shall we conclude this session?
Yeah, not from my side.
Yeah, I'm also done.
You have used Java for this, right? For implementation?
Come again, sir.
Because I've gone through the abstract and it's been the case that you have used Java. Which language you have used?
Yes, we use Java for the implementation, sir.
Okay, so but we are having some better option as a Python. So any specific reason why you use Java?
Actually, we can as well use Python for this one, but we randomly selected Java for this experiment, sir. We can as well use Python, and MATLAB can also be used for the implementation of this experiment. We are aware of that, but we choose to use Java for this experiment, sir.
Okay, okay. Thank you. Done from my side.
Okay. With this, we have completed all the paper presentation of this session today. Now, I take this opportunity on behalf of NIT Raipur and organizing committee of the conference. I thank you all for sparing valuable time as well as providing valuable insights through the authors. Thank you one and all for making this session successful.
Kavita,
Yes, sir.
may I request to all participants for a group photo?
Okay. I request all the session chair and participant to switch on their videos so that we can take a screenshot of the session.
Can you stop your presentation, please?
Okay, sir.
Unshare your screen.
So for various diseases and not just COVID-19, there have been multiple vaccines from different manufacturers. So the efficacy rate of vaccines varies from region to region and from person to person. That we know.
Kavita, who is taking this name?
Yes, sir. I'm taking.
You are taking. Okay.
So the study conducted by investigates.
Okay, thank you all for making this session successful. You can log out of this session. Have a nice day.
Thank you, Dr. Hazrat Ali.
Thank you.
Welcome.
Thank you for the opportunity. It was great.
Yes, thank you very much, Dr. Lalit Purohit. Thank you, sir.
Thank you very much, sir. Thank you for
Greeting
being
from Nigeria.
part.
Thank you for the opportunity.
Dr. Dheeraj Rane, thank
sir.
you. Thank you all the
Thank you, sir.
participants, presenters. Really, it was very nice session, well conducted. Thank you. Thank you, everybody.
Yeah,
Thank
thank
you,
you.
sir.
See you.
Thank you. See you.
Thank you, sir.
Who will present the next paper? You send request for 2 papers actually. I may not pronounce your name correctly. Sunday, I'm asking. Yeah, you requested for 2 papers. 2 papers were scheduled today only. So who will present the other paper?
Dr. Awotunde should present the second paper. Is it? We are actually having issue getting the exact section where he's going to present.
Okay.
So
In different
the other paper is
There are two other papers are also. Have you any idea about those papers? These are also Professor Mishra's scholars.
Yes, he's one of our scholars. He's one of our contributors.
Okay.
So can we present that one now?
No, you told about only, you requested, you write me mail about two papers only, but there are two more papers which are scheduled on 14 Monday.
Monday. So what is the title of the paper, sir?
Yeah, you just wait, I can share.
Yeah.
So the decisions are made based on post-based and vaccine-based factors. The system considers data points like age, sex, and medical history, and allergies of host. And to the event, with the rate of the vaccination, what are the symptoms of the host? Then the main direction. This is our system. So it is
Yeah, I shared in chat.
Okay, sir.
This is one. I'm also sharing the other. If you can help, then please provide their detail or at least inform them. We have uploaded the schedule.
Development of this no, this first one is not our paper. Okay.
These two papers, their IDs, you can also check in the schedule. Their IDs are
these are not our paper.
okay, no problem. If you know,
I know one of the, I know two of the authors.
You can inform them. Otherwise, yeah, I have requested, I have sent message to the to Professor Mishra. No issue. Thank you very much.
I did not appear in the picture again when I was trying to share my screen.
Yeah.
Can you snap you and I?
Yeah. Professor Mishra already informed me that there is issue of internet connection, internet speed in Nigeria. So no problem. That's why I'm asking, can I share you can I share your presentation for you? Yeah. Although your presentation was very nice. Thank you.
Thank you, sir.
Thank you. Thank you for.
Can I share? Can I get your contact?
Yeah. My contact is yeah. I will message you. I'm just messaging. Please save. This is my number.
All right, sir. All right, sir. Thank you, sir.
Thank you very much.
You're welcome, sir.
Welcome. Two more keynote speakers are presenting their keynote talk tomorrow. So you are requested, your colleagues, those who are interested, please join those keynote talk. Okay. Thank you.
All right. Thank you, sir.